Today, we're building a jetpack system in Unreal. We'll add thrust, a health bar for fall damage, a fuel bar with regeneration, and sound effects as a final touch. We're covering key blueprint principles, so even if you don't need a jetpack in your project, stick around and learn something new. Let's start with the first-person template. So find the first-person character blueprint. We can add a new node graph if you want to keep organized. We'll call this one Jump and Jetpack. In our main event graph, we can drag select, then Control X to cut our jump input functionality, and Control V to paste it inside our new node graph. We'll need some new variables for our logic here. If you're not sure what a variable is, it's essentially just a piece of data we can set and update as we build our graph. So, for example, fuel amount is a variable we can set and update as we use our jetpack and fuel is spent. Let's create fuel amount as a variable and the variable type as a float, which is basically just a number with decimals. Compile the graph to get access to the default value, and let's set that default to 100. So our fuel starts at a value of 100, which we can imagine is 100%. We'll use fuel amount to track when we run out to shut off our thrusters. While we're here, let's add a few more variables we know we'll need. Fuel consumption rate is a good one to add. Let's make the default something random like 10 for now. Now, how do I know what should be a variable? Think about numbers and values that are likely to change or that you'll need to reference in your graph more than once. For example, you might let your player upgrade their jetpack at some point during the game, and fuel consumption rate might go down. With that logic, let's also create another variable called thrust power. We'll make that 10 as well, and maybe even fuel regeneration rate. Compile, and maybe 5 for this one, so we regenerate slower than we consume. You don't need to know every single variable or the default values that you'll need right now. You can always add more and tweak these variables as you go, but I like to sit down and try to think of a few when I start. It helps me have a framework for what to build. Let's also add Jetpack is active and make this one a Boolean. Unlike a float number, which was a decimal, a Boolean is simply on or off, like a switch. This variable might come in handy for things like telling our game when to play the jetpack sound, or when to spend fuel. Essentially, whenever this Boolean is on or true. Since we don't want to start the game with an active jetpack, let's keep the default value unchecked or false. Now we're ready to write some functionality. We're starting with the default jump logic because we already have this nice enhanced input action called jump. Again, this is all just in the first-person template. This, I happen to know, is mapped to the spacebar. I think this is a great starting point because if we have fuel, spacebar can be the jetpack. If we're out of fuel, it can still serve as our default jump. After we jump, let's set a variable. Here's a nice shortcut. If you wanted to get a variable, hold Control and drag it into your graph. That gets the jetpack is active Boolean. Just delete that. And if you want to set a variable instead, hold down Alt and drag. Now, after we jump, we can set jetpack is active, and let's set that to on or true. So we know we've pressed spacebar and our jetpack is active. After the jump is completed or we let go, let's set the variable again. So Alt drag jetpack is active, and this time let's leave it unchecked or false. Now, when we press space, it should turn our jetpack on. When we let go, it should turn it off. Lucky for us, we can always check this. Let's add a print string to this section and let's say on in all caps. Control D to duplicate that print string, and for this path, let's say off. Now compile, save, and let's do a playtest. When you press space, it should say on just once, but when you let go of space, it'll say off. Perfect. Let's delete those print strings. Now we know it works. Now we're ready to trigger the jetpack. You might think it'd be good to put the jetpack thrust logic in the ongoing input. After all, ongoing should keep the jetpack on as long as we're holding it down, and it would check every frame to trigger the shutoff of our thruster after we let go. And that could work for a bare minimum tutorial. The problem is ongoing fires every single frame. What's inconsistent about that is someone playing our game might get, for example, 60 frames per second. That's firing off our thrust power 60 times every second. But someone else might be getting 120 frames per second, essentially meaning they get double the thrust power. This is pretty inconsistent and tough to plan for. So I'd like to keep any constant action, like thrust being held down, on a tick interval by the second, not a tick for every frame. For example, I can set a tick interval to something like 0.05. That's 20 times every second. The nice thing is, that's much more consistent than frame rate that can change from computer to computer or one player's console to another. Let me just show you what I'm talking about. Let's put a print string off of ongoing. Now, when we play the game and hold down spacebar, it prints hello about 120 times every single second. All right, let's add an event tick. This is essentially the same thing. We still print hello about 120 times every second, even when our spacebar isn't pressed. But let's add our tick interval. Just go up to class defaults, which will change the tick for this entire first-person blueprint, and let's change it to something dramatic, like 1 second. Now, when we play, we print hello only once per second. Since the message clears every 2 seconds, we only get 2 hellos. As you can see, setting a tick interval lets us rely on time, which is way more consistent than a random frame rate. And by the way, this little tick interval setting does not apply to the ongoing in the input action, which is why we're just using this event tick instead. Let's change that tick interval one more time back to 0.05. Like I said, that's a consistent 20 times every second, which should be fast enough to feel responsive and calculate velocity, and most importantly, gives predictable power to things like thrust or fuel consumption, even across different players and different frame rates. You could test that again, but we can pretty much delete the print string and move on. We need to know 20 times every second if our jetpack is active. To do that, let's hold Control and get our jetpack is active variable. Remember, this is set every time we press or release spacebar, and it's checked basically 20 times every second. So we get or check if it's active, and we use that to drive what's called a branch. A branch is used all the time, so it has a shortcut. If you just click and drag and press B, it'll appear. Just connect that, and now if it's true, if the jetpack is active, we take the high road. If it's false or not active, we take this false path. So if it's active, let's do another check. Click and drag and press B again for another branch. For this branch, let's check our fuel. Just Control drag fuel amount to get. For this one, let's click and drag, let go to search, and type in the greater than symbol on your keyboard. So now, if the fuel amount is greater than 0, we can take the true path. This is just a quick branch to check if we have fuel. We'll cover the false path a little later. Just my own preference, I like to handle all the true stuff first. So if our jetpack is active and we have fuel above 0, then and only then we can fly. Let's add the node launch character. Now, how in the world did I know to search for this random node? It's one of the frustrating things about tutorials. Some things will just come with practice. All I can say is it might be a good idea to take note of this node somewhere. Maybe bookmark the video in a document somewhere, because someday you'll be like, what was that node that launches the character again? Oh yeah, Riley said it was launch character. So that's one that I just knew. Now, just like the name implies, this will give us a launch velocity 20 times every second, or on every tick, for as long as our jetpack is active. In this case, as long as we hold space and we have fuel. Now, we could just type in a number on the z-axis. In fact, let's do that. Let's type in 100. Now you can test out the flight so far. The nice thing about this method is it simply adds z velocity or up velocity to whatever velocity our character already has. So if we're falling, it takes time to build and reverse that falling velocity. It feels pretty natural already. Back in the blueprint, remember though, we have this nice thrust power variable. So let's get that, control drag. Now the problem is we just want to plug this float into the z value, not x, y, and z. To do that, simply right click and split struct pin. That splits our vector or a collection of numbers into individual inputs. Let's use thrust power for z, and let's just change that thrust power variable default to 80. I actually think 100 felt pretty close already, but maybe just a bit much. If you appreciate this tutorial so far, check the pinned comment to learn how you can support the channel. Moving on, we have our jetpack working, but now let's spend some fuel. After we launch the character, let's set our fuel amount variable. Remember, set is alt drag. Instead of setting this to 0 right off the bat, let's count down. Let's start the countdown with whatever our fuel is in this moment. So get fuel amount with control drag. Remember the default was just 100. And let's subtract our fuel consumption rate variable, get that as well, and let's search the subtract symbol for the subtract node. Now, if you set that equation to be the new fuel amount, and we try this, let's print string to see what's going on. Let's just put fuel amount for the text. This won't quite work yet. Let's see. When we spend fuel, it goes from 100 to 0 real quick. That's because our default fuel consumption rate variable is 10. So that's eating 10 units of fuel 20 times every second. Let's try a default value of 1. And that feels a lot better. Again, the reason stuff like fuel consumption rate is a variable is so that if we change that in our game, say the player buys an upgrade for better fuel economy, then we could just change the variable in one place and it's taken care of wherever we might have it. Cool. We have fuel consumption, but what about regeneration? For that, let's backtrack to our first branch. Is the jetpack active? We know the true path. Let's explore the false. So when we're not using the jetpack, we can regenerate. If it's not active, let's set the fuel amount variable again. This time, let's get the current fuel amount, and instead of subtract, let's get and add our fuel regeneration rate. Let's delete that old print string and let's print this value instead. Now, when you play, and this is why consistent testing is a must, you'll notice we start regenerating on top of what should be our maximum of 100 fuel. This is a problem, but nothing we can't fix with a bit of simple branch logic. When in doubt, branch it out. So drag off the first branch false and press B while holding that down for another branch to appear. This time, off the fuel amount again, let's check if the fuel is less than 100. We really only want to regenerate fuel if we're anywhere less than 100. Now, test again, and as you can see, it's working. You might get some values slightly over 100 when you regenerate, like 102, maybe 104. This is a small error, mostly because we're firing this logic 20 times a second, and sometimes things fall slightly out of sync. Honestly, it's nothing that'll cause problems, but if you're a bit bothered, you can always come here before set fuel amount and say clamp float, and make a minimum of 0 and a max of 100. That way, we never exceed 100 fuel being set. But, like I said, this probably doesn't matter. Now we have thrust, we have fuel consumption and regeneration. What else? We need fall damage, we'd like some sounds, and of course we should have an interface because no player wants to look at a bunch of numbers and a print string. They want to see a nice progress bar. All of that's coming in future parts to this training, so subscribe and I'll be back to finish this off before you know it. If you don't want to wait, all the parts are available right now as early access for all my Patreon subscribers of at least $3 or more. That's patreon.com/RileyB3D. It's by far the best way to support this channel. For now, let's delete that print string and zoom out to admire our work so far. Hopefully, I'll see you in part 2 and beyond, either right now if you support on Patreon or over the next few weeks. Again, we'll wrap it up with fall damage, thruster, and damage sounds, and of course, our fuel and health interface. Thanks again for watching.